to take advantage of that. Okay, I see marquee. The second thing that we can take advantage of is someone reading the question, and that's for, how big is this question? He said, what's that, buddy? So there's an option to read for points. This is worth 15 additional. Yeah, go ahead. One for water coming out. I'm going to start teaching y'all. So let's just start seeing y'all out there. Do stuff. All right, now, you said you going to do it or no? Dang, you're doing a double walk. You're doing a pop. I'm going to tell you the points of the recording afterwards, but go ahead, man. And I'm going to knock this out again. The we do. Yeah.
A survey consists of a battery connected up to 3 possessions, 66.15 ohms, 29.5 ohms, and 177.25 ampere. The total circuit resistance is 0.94 amps. Find the end of electrical force of the battery.
Yep. Yeah, 15 right there, man. All right, so open up that book, and I'm going to tell you 2 parts of notes. Now, 760 is only one part of what you need. You're going to need 2 equations from the past, kind of like Yu-Gi-Oh! You need 2 track cards or something. 760 is where we're going to start it, but I'm going to tell you the actual pages of your equations. Yeah, you remember, you would have part 1 and part 2 of your notes already. You did yesterday's. So what is part 1? Of course, it's going to be about Ohm's law. All right, so we go back. I think Ohm's law was 751. Remember this? We did this for 3 days. If you got this in your Google Notes from yesterday, you can copy that box, put it in today's. What else am I going to do? Well, I'm going to talk about the parallel, equivalent resistance for parallel. Resistors and parallel. All right, so let me get started on this. Okay, so what do we know? We need those tools again from our past. First one is our old friend, Ohm's, like you're meditating, Ohm law. And if you did your work yesterday and the day before, you would have this box already typed. Going to use your Google Notes or your Google Drive correctly. So again, that's V is equal to I times R. There is another version when I always say it, I don't know if y'all know it till now, a new word that you might not like, I've been saying it, electromotive force. That's what epsilon is, that little weird looking 3E, it's epsilon. So if you're talking about regular batteries, then use V. If you're talking about something with probably a waveform electromotive force, then yes, you got to use epsilon. Is equal to, they told us in the problem, I tot, or I total, so subscript that, I-T-O-T, right? Multiplied by R sub EQ. That's our equivalent resistance. What are these measured in, so you'll know? Well, V or epsilon, not E, or 3, is measured in volts. That's how you know what number that is in your problem. You're talking about any type of current, I, you see a number and it has AMP bias, or AMPS sometimes, that's current amps. And these, whether it's REQ or just a resistor 1, 2, or 3, it's measured in terms of ohms. But I'm not gonna lie, I prefer to use the professional version, which is omega, the Greek letter. We spell these out. When you talk about epsilon, it is spelled EP. S-I, I think, L-O-N. When you're measuring for this, looking for this Greek letter here, which looks like a God of War symbol or something, that's just omega. Okay? Just so you know. All right, we'll box this off. This is part 1 of your notes. Please try to draft this up because you have the quiz. You don't want to be having to type all this up on Friday. Be able to pick and choose what you need, like an arsenal of stuff, of information. You find this box, again, on page 751. Number 2, we need the equivalent resistance calculation. So flip to that page, and that page is 758. We also got this yesterday. So again, it's equivalent resistance for resistors that are resistors in parallel. That are in parallel structure. How do we use this one, right? We break out the equation. That's that long fraction thingy. People don't like fractions. So it's like 1 over R sub EQ. 1 over R sub 1 plus, you got 3 resistors in there, 1 over R sub 2 plus 1 over R sub 3, okay? The plus dot 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 feature is if you got more than 3 resistors. You got resistor 4, 5, 6, you have R sub 4, R sub 5. That's what that means, okay? All of these are measured in terms of, we'll talk about it. Since they're in fraction mode, you'll see them measured like this. It'll be omega raised to -1, which is not cool. So we flip the fraction. We say ohms raised to -1. That makes sense to you. That's actually what's happening here. You find this part of your notes again on page 758. All right? Now, let's get our ingredients on the table so we can solve this problem. Part 3 of your notes. What are your known and unknown? Let's see here. This is where we start picking out what we need for the problem. So known values. Let's take a look here. So looking at this problem, we know 3 resistors. It says 3 resistors. So it's R sub 1, R sub 2, R sub 3 in that order, right? So let me begin my journey. So R sub 1 in this case is going to be 66.15. So R sub 1 is equal to 66.15. And that would be omega. R sub 2. What is that? Look at our notes, 29.05 omega. R sub 3, that is, what do we put? So 177.25 omega. So if you got these notes from yesterday, you can just copy what you got and change the R's and stuff to the numbers here. See how taking notes every day helps, especially when you're doing it digitally. So what else do they tell us we have here? We know it's in parallel. They told us the total current is ITOT. So it looks like we got to use this electromotive force version when we have waveforms involved. So that'll be epsilon. It's not a 3 or E, I keep saying that. And not epsilon, sorry, I total. I'm going too fast. That goes over here with the unknowns. So I total was given as, what did they say? 2.94 amps. What's unknown here? Well, that's epsilon, isn't it? That'll be the electromotive force. Some number in volts. We got to figure it out. So the best strategy I would think is we combine all our resistors into our REQ, and then we go over here and we get epsilon. So we got 2 things we need. We got I total here, but we also need REQ. We can get REQ by looking over there to our new tool that looks like a big old fraction, right? We'll box this off. This is part 3 of your notes. Now for the main event. Let's figure out what REQ is, right? So I should put over here, you got to find 2 things. Of course, REQ, and then epsilon. Okay? So let's find them in order, right? So I'm gonna say, hey, part 4 of your notes, you're gonna say step 1. You need to solve for REQ. To do so, you need to first use this, so you can combine all the resistors. So let's write it out. Use your equation maker or use parentheses to group your fractions. So the equation is this, right? We already wrote this. Some of y'all already got it typed. Just copy it from wherever you got it. And then that's, what do we got? 66.15 there. Plus, we got, that's R1. R2 was 29.05. And plus the last one, right, which was I think 177.25. And that's omega as well. Use your calculator. So it becomes 1 over REQ is equal to. Grab my calculator. Oh, these are so cool. You can use the fraction maker to do this, especially if you're taking a quiz or you're doing your YouTube problems. So if I hit fraction, I got 3 fractions I gotta make. 1 over, come downstairs, it's 66.15 plus. We have another fraction to make. It's 1 over, come downstairs, it's 29.05. Plus, another fraction there. 1 over, and then it's gonna be 177.25. I'm gonna add all these up. And again, use the fraction maker because you're going to do like the common denominators and stuff. And then you don't have to do all that. You can just use this thing. So the answer comes to be, and this is not the final answer for resistance. We got to flip that number like I showed you last time. So to do that, how am I doing on time? Okay, we're almost out of here. So to do that, it's 0. What it's telling me in the book, 0.0552. That here, 0.0552, and this will be an omega raised to -1 because it's 1 over REQ. We need REQ though. So here's that technique I showed you again that might be on an SAT or a big test you have in the future. How do I flip a fraction so I can get just REQ? Well, I gotta raise everything on both sides to the power of -1. That's all that means. So I do it here. And then once you do one side, stay consistent. Algebra is all you're doing here, you're doing the other. I'm gonna flip that fraction. And this will get rid of that -1 over the omega there. So when we do that, it simply becomes now REQ, which is what we wanted, is equal to and just grab my calculator and I just raise that number previously I got to the -1 power. So it's 0.0552, right? And then I'm gonna hit the caret button on here. It's the upside down V. It lets me raise to a power, and I'll put -1 in here. I get 18.12. And this would be omega now, not omega to -1. All right, we're almost at the finish line with this. This one is not as bad as yesterday's. Yesterday was a monster. Twice the board was filled up. You're gonna probably get right here and that's it. Watch what happens. Since this is already set up for epsilon, I don't have to do any further algebra. So I can just take this tool and that'll give me my electromotive force, the battery power. So we'll say part 5 of your notes is you're gonna say, hey, step 2. I need to solve for epsilon. This is our battery power of the system. In this case, it might be something close to an AC circuit where you have it pulsing up and down as a waveform. So the equation for that is epsilon is equal to I total, which we have, multiplied by the REQ we just found, And now we just plug and play, right? And drive this car off the lot. So epsilon is equal to, we know I total to be this. Multiplied by, we know our RAQ, we just calculated that. And we just use our calculator and we're done with this thing, right? So I get a yield of 53.27 volts. So the problem changed just a little bit. I told you you used some of your stuff from yesterday, but not all of it. Go searching for something else. All right, so that was, I want to say 45 points for recording. Who got that this time? I think it was you, Marquis, right? All right, backed up today. Make sure you turn your document in so I can at least see it.